Okay, the first thing you'd like to do when you're performing the Atterberg limits, also known as the liquid, plastic, and plastic index, we need to calibrate our device because it has to fall at a 10 millimeter for a 10 millimeter drop. Okay, so the first thing we're going to do is calibrate our device. Put a piece of masking tape over the center of the circle where the cut makes the drop. We like to extend it so that way you do not forget to remove it. If there's not a circle, you can also use carbon paper to make a mark. And then the bottom of your grooving tool is 10 millimeters, and that is used to calibrate it. So what we're going to do is we're going to slide this block up until it meets the tape that intersects the drop circle. Okay. Now what we're looking for is we're looking for a dull ping. So we're going to crank the liquid limit device and adjust it appropriately. As you can see, that's lifting higher than the 10 millimeters, so we're going to adjust it. We loosen the set screws, and this back screw makes it go forward and backwards. So when you have a dull ping or dull thud and the cup is barely moving, that's when you know that you're at your 10 millimeter mark. So now we are calibrated.
Check for those screws. Check for those screws.
And before, and at this point, you need to make sure that there's not an excessive groove in your cup, and make sure that everything is held together well. No loose screws, no parts that are worn, and that everything fits together tightly. So now that we've calibrated our device, the reason that we extend this tape is so that we cannot forget to take off this tape, because if you do, then your test is invalid. So now we're ready to start our testing. Okay, at this point, we now have approximately 100 grams of -40 material in our porcelain mixing bowl. The way we got to this point is we dried our soil according to ASHTO specifications, and then we sieved it over a number 40 screen, and everything that was retained on the 40 screen, we used only the weight of gravity with our mortar and rubber covered pestle, and we ground it down to make sure not to change the molecule size, and we dry that to only a maximum temperature of 140 degrees Fahrenheit or 60 degrees Celsius. You do not want to go over that temperature because you could alter the organic composition, which will make the soil react differently while you're performing your Atterberg limits test. So now what we're going to do is we're going to take our beaker and add between 15 and 20 milliliters to start. I'm going to go ahead and start with 20. And we're going to mix this thoroughly. And at this point, we're going to, if we do not feel that the soil is moist enough, we're going to add only 1 to 3 milliliters. And at this point, no dry soil can be added. And what we're looking for is a thick, cake-like consistency, maybe like creamy peanut butter. Okay, now that we feel that we have the consistency of the soil that we need to make a cake, we're going to go ahead and we're going to put it in our dish. Now you don't want to fill up your entire dish, you just want it to be like it was filled with water, so it's going to be level to about this level. I'm going to use as few strokes as possible to make yourself a flat cake. Make sure there's no air entrapped. Now we're going to take our grooving tool, make sure that it is clean. After we take our damp rag, cover this to make sure we don't lose any moisture from our soil. You can do 6 strokes up or back, with the last one scraping a clean groove down the middle. 1, 2, 3. Now we're going to take our spatula. We're going to trim the excess away from the groove. And then you cannot hold the base. Many people will put their hand behind their back as a just to make sure that they don't. Now you're going to crank this at 2 revolutions per second. It's 27.
That's legal.
Okay, so now we have a 1/2 inch closer at 27 blows, which is legal. In a perfect world, we would like it closer to 35, but we're going to go with it. So what you're going to want to do is you're going to want to take your sample from where the groove closed. You're going to cut laterally this way. You're going to scoop it out like this. Now these tins have already been weighed and recorded on your worksheet. So I'm going to take my sample, make sure that the lid is closed, and I'm going to take it and I'm going to weigh it. Now at this point I'm going to add this soil back to my soil cup, my porcelain dish, mix it up a little bit. Then I'm going to take out a 10-gram sample for my plastic limit test because these are run together. I'm going to weigh this to make sure it's approximately 10 grams. I'm going to sit it on my frosted glass for it to season while I continue with my liquid limit test. From this point on, I'm going to repeat what I've already done, but on the first trial we had to have the blow count between 25 and 35. The second blow count we had a little more moisture and we ate between 20 and 30, and the third and for the third trial we had a little more moisture and we needed between 15 and 25. Once we get all our points within our correct blow count, within our correct blow counts, we have to make sure that the first one and the last one are at least 10 blows between each other. Which means if you get your first one on 32, then your last one has to be at least 22 to make sure that you have enough range in between your first and last one to make a good flow curve. So now we've gotten our liquid limit portion done, 10-1, 10-2, and 10-3. Now we're going to move on to our plastic limit, and this is a 10-gram ball, and we're going to break this into 1.5 to 2 gram pieces. I'm going to take this over here and weigh it. I'm going to roll it into an ellipsoidal ball. Now I'm going to roll it here to try to release the moisture. And I'm going to do it 80 to 90 strokes per minute. One stroke is up and back. And I'm going to do it until it goes into 1/8 of an inch thread. And a good practice is from your liquid limit device, this pin that attaches the cup to the stand, is 1/8 of an inch. So that's how you can measure to make sure that your thread is the proper diameter. After this, I'm just going to reform it. Put it back into an ellipsoidal ball. And continue. Now I'm going to do this until the soil can no longer be rolled out into an 1/8 inch thread. For this to be a valid test, it has to be able to be rolled into an 1/8 inch thread at least one time and within 2 minutes. So as you can see, it's starting to break apart. We're getting close. I take my pen and see that I'm close to an 1/8 of an inch thread diameter. I'm going to reform. Try to roll it out again. As you can see, it's starting to break apart. That's how we know we've reached our plastic limit. We immediately take it. Put it in our tin that we've designated for the plastic limit. Make sure that we cover it. And then we will take off another 1.5 to 2 gram piece and continue until the entire sample has reached its plastic limit, and we put it in the tin with the lid on and weigh it. Okay, so now we have completed our liquid limit and plastic limit analysis. What we're going to do now is we're going to take all of our tins, our 3 liquid limit tins, and our plastic limit tin. We want to make sure that the lids are cracked. Now we're going to dry these at a temperature of 230 plus or minus 9 Fahrenheit or 110 plus or minus 5 Celsius. And we're going to dry those until they reach a constant mass. Then once we've determined that they've reached a constant mass, we're going to put the lids back on them. We're going to wait till they're a comfortable handling temperature. And we're going to weigh them to get our final weights. Now at this point, since we have all of our final weights, we have our blow counts, our moisture content, we can then go to our semi-logarithmic graph paper and create our flow curve. And you can see that demonstrated in our slideshow.